So why don't you take this map here, this is on page 1038. Why don't you sketch in 5-foot contours, start with the 800 footer. So mark the points that are at 800 feet and then connect them together. Is what I mean by that. So what you're looking for is a given line that has a point above and a point below 800. So for instance, this line right here has a point above and a point below 800, and then notice you're going from 802 down to 794. So that's 8 feet. So you're quite a bit closer to the 802. So I'd estimate 800 being about there. So do that for the other points you can find and connect the dots and see if you can get a contour map made out of that. So and normally what I do with these is I start with a point in the middle of the elevations, upper middle, and then the other contours, once I've got the one line, tend to be kind of parallel to the one I've drawn before. Something like that for 800, roughly. You all doing all right with that? May not be exactly that because we're just sketching. Notice the use of the word. I'm not saying interpolate. I said sketch. So. All right with that? Any questions? Now we're doing 5-footers on this. Once you got the one line, you can start to put in the others, you know. The first one's the hardest one, but the others are going to be not exactly parallel to it, of course, but, you know, they'll be kind of parallel usually is how that goes. So 795, you know, you could look at that and just kind of keep going, you know, and get the thing drawn up. You know, and I spent a day or two out on a site. We were just turning angle and shooting distance. There were hills and little valleys all over the place, and you know, got all the data, turned it into the drafter, and the drafter did this and came up with a good map of it, you know. That was the start on doing the project, was to have a good contour map of the site. So it's just a matter of interpolating in the elevations you want. And if you're sketching, it's not, it's not exact interpolation. I mean, it's dirt out there, don't get too worked up over it kind of thing. It's just, it's not like dirt is kind of a irregular surface, so we don't get too worked up over it. Now, if it says interpolate, then you would get a little bit more worked up over it, but just sketch, you just sketch them in and get them good as you can get them, but don't have to get too worked up on that stuff. Is that about 795? Not sure. I don't think I missed anything. Okay. So that's a good example. You can see how it's roughly parallel, but not exactly. But having the one in helps you get the second one. And, et cetera, et cetera. You just kind of keep going through. Let's see if we get that 805 in there and see what you come up with.
Do a line for 805.
Yeah, let's get that and see what you do. Yeah, that's kind of what I was after. Yeah, you'll notice when you do 805, the other ones go off the map somewhere, right? You don't know where they go. But 805, that's all on the site, okay? So 805 doesn't run off the map. That's the idea with that's kind of why I want you to draw that, just to see the difference there. So 805 would be something like that, I think. Okay, so we got a little peak in there. So that's basically how you create these. So we got any questions on that bit? So let's have a look at doing a contour map of a survey then. And this will be your homework there, or part of it anyway. So it starts on 1051, and what you've got there is the data there from the survey. You've got the sketch from the survey on 1052 to help you make the map, and then you've got some graph paper on 1053 to put the map. Now, the first thing you want to do here is take that data and center the map, okay? Make sure the map will fit on your graph paper. So we got a scale of 1 inch to 50 feet, 2-foot contour interval. You can eyeball in your contour lines. So there's the data. So we got 22 points. This is kind of like that ramp survey you did, except we're going to add contours. We got a northing and easting and elevation. And then we got a description. Okay, that's the map that the surveyors came up with based on the site. So they got a house, 4 trees, lot corners, and some shots on the road and the driveway. Notice the width of the driveway is called out. Now, the other thing you'll notice here is this was a conventional survey, so we're on page 1052 is where we're at. By conventional, I mean they used a total station. They didn't use GPS. So it looks like the instrument was over here somewhere, and they were able to pick up 3 points on the house, which generally at a minimum is what you want. Okay? Now, if you're using conventional equipment, you can't see the whole house. You can't see both sides of it, of course, because you got, the house itself is in the way. So typically what you do is you get 3 points on the house, you shoot them in and get coordinates on them, in this case 9, 10, 11. And then from there, you take a rag tape out. Rag means not metal, it's kind of fiberglass tapes. And you pull distances around the foundation. The assumption then is that the foundation's square. So if you got 3 points on the house, plus you measure around this foundation, you can create a map of it, okay? That's the idea. And the reason for that is you can't see all the corners on the house from one setup with an instrument. Okay. So we've got the trees in there, lot corners, driveway, points on the road, and the house points plus the dimensions. Now notice that you got the widths of the driveway 28 and the road 30. So you can offset your points on the driveway 14 feet either side to get the driveway. So that's 14, that'll be 14. Then the road, you'll offset a full 30 that way, okay. All right. So that's what we've got. So let's kind of get a start on this. First, let's get this thing centered on the map, okay? So on the graph paper, I mean. So you've got these 22 points. What's the highest northing you've got, roughly? Yeah, 1462 there. That's pretty much it, isn't it? Down at the bottom? Okay. So I'd put that in here. How about the lowest northing? What do we got?
1104.
Yeah, it looks to be 1104. Okay. So that gets you the range for north to south, okay? So the furthest south point at the bottom of the page has got to be at least, if you're on even 50 feet, it'd be 1100, maybe even 1050. Then count your way up and be sure you get to at least 1500. That way the map will fit. You with me there? Okay. And then how about the eastings, lowest easting, is that 442? 439, okay, so there we go. So these are like the corners, so to speak. And then highest easting, what do we got? 772? Or, oh really, where's 717? 717, okay, thanks, okay. All right. So just be sure, that's kind of the range of your map. So north-south, it starts down at least 1104, which should be 1100 on an even 50-foot grid, but maybe even 1050 to get you a little space so you're not putting stuff right on the edge of the map, especially because you got to offset 30, don't you, on that point? I mean, that 1104, what is that? That's the edge of the road, yeah. So you need 30 feet more than that because you're going to offset that one down 30 feet right there. So I think you want to be starting at 1050. So you got enough room to put that, okay? So when you set up your paper then, probably start down at 1050 and then just start working your way up. Each main grid is 50 feet. And just be sure before you start, drawing everything up that this is going to work, that you got enough room. And I'm a little bit out of scale on how I'm drawing this, but you want to get at least to what is it 1450? Actually, it's 1500, okay? And I think you got enough for that because I think you got 10 big grid kind of spaces here. So 1050, 11, 1150, 12, 1250, 13, 1350, 14. I'm up to 1450 roughly. Let's try this one here. So 1100, 1150, 12, 1250, 12, 13, 13, 50, 14, 14, 50, 1500. Yeah, I think you got enough room there. Yeah, you can get it centered so it'll fit. You just want to think ahead, so you don't run out of space to put your map on. Same thing east to west. You're going to start at 400 and end at 750. And those boxes go on 50-foot intervals. Okay.
So what if you have a house that's just like a square, like a warehouse or a barn? You can't get 3 points. I guess you could set it that far enough.
If it's square, if you can get 2, you can get away with 2, if you had to. But generally, the general convention is to get 3.
I guess you could just go straight out to a corner and get 3 points.
Yeah, you could. You ought to be able to get them.
What if it's a circular house?
Yeah, right. What if it's a hexagon? What if it's Windsor Castle? What do you do then? Okay, so get that grid set up, then plot up your points. And I would just plot up all the points first, but put next to them what they are. So like point 1 is a road, RD, Remember to switch the easting and the northing, because we're quite used to doing X, Y. These are YX. Remember to switch those. Plot them up. Put next to them what they are, point number, what they are, and their elevation. Put that in kind of light. Then get out a straight edge and connect the lot lines. Get that house in there. Get the road line. Offset the road 30 roughly. Offset the driveway either side. Get the house in there. And then being as you got those elevations in there, now you can start to interpolate in the contours. If it's easier, you can do it on AutoCAD if you like. Again, just remember to switch those X's and Y's. That's the thing, okay? Maybe it's not. Maybe it's easier to just do it by hand. Whatever, whatever works. It's fine. Okay? So that's part of the homework there is to do that. So you'll be turning in page 1053. And so what I want there is a finished map with the features on it as shown on 1052 plus the contours. That's what I want out of that, okay? And that's a real typical kind of product that you make when you're surveying a plot plan, they call that. All right, now let's have a look. So are we good with that? We good, all right? And that's pretty similar to what you're doing with your ramp project with the one addition of contour lines, okay? So not only are you plotting up the points, you're also putting in contours on this one. The contours would be kind of funny on that ramp project. Any sort of those straight kind of lines get kind of funny with contours. They look a little goofy, so there's no reason to, we won't do contours on our ramp project. With the walls and the ramp and all, it'd be kind of hard to do and make it look like something. Now let's look at this. What we did out there for the last thing here was we did trig leveling, okay? So let's have a look at that. And this is a ways back in your book. It's here. So these are vertical angles. And this is kind of back towards the beginning of your book. The homework's on 359, and the explanation's on 341. So 341 is where we're at. So vertical angles is that was a part of what we were doing out there on Thursday. So what's going on with a vertical angle is you use it to find elevation differences. Now, if you want to get something just flat on a point, use a level. I mean, that's generally what I've been told, and I stick with that. So if I'm grade staking a real flat pipe like a sewer or something here in the valley, I'm going to use a level. I'm not going to mess with a total station. But I have heard of people using total stations for this, and you can do pretty darn well with it. But, if it really matters, I'd probably use a level on projects. But you can do good leveling with a total station too, and you do it using trigonometry. So if you've got this vertical angle here and a slope distance, you can use trigonometry and find that vertical offset distance there. Okay? Now, there's one little bit of a twist on this, and that is that if you're using an old American instrument called a transit, which is a very old instrument now, if you see them around, they're going to have 4 leveling screws. They might have a Parkerized kind of finish on them. They'll be painted green sometimes. The real old ones are brass, kind of real pretty instruments. Those things, they're going to have 0 as a horizontal line, flat line. And then you measure up from that with what's called the angle of elevation. But nowadays, most everybody uses theodolites. That's what goes into a total station. For a theodolite, 0 is straight up. It's called and you measure down with that with a zenith angle, you call it. Okay? So you're actually, with your instrument, you're actually measuring that angle is what you're doing. So what I'll do, I'll take 90 minus that angle to get this angle in here that I'm calling alpha. Okay? So just understand, some of you were asking what that angle was, the V angle on your instrument. That's the vertical angle. That's this one right here. So if you're shooting a flat line with a theodolite, it's that V is going to read 90 or 270, one or the other, okay? Because you're measuring straight up as 0. Now, if you're going to do this trig leveling, we kind of went over this for the lab. You start with the elevation of the point that you're set up on. You add in your lowercase hi, that gets you up to the telescope. Then you add in this vertical offset, sine alpha times distance, which your instrument on the lab did for you automatically, right? So what we're doing here is we're starting on the ground, we're coming up by the hi to get to the telescope. Then we're going to add sine of that vertical angle times the slope distance. What that is this right here. That gets you up to the glass on the prism. And then you're going to subtract off the height of the rod, and that'll get you back down to B. Okay. So that's the basic formula for finding an elevation on the ground using trig leveling.
You have to use a total station.
A total station or a transit. You can't do it with a level because levels just shoot flat.
Right.
You need something that'll turn you an angle.
If you could get the level to like angle up.
Yeah.
And then shoot the distance, you could do a trig.
Yeah, right. If you have, there's other instruments you could use.
You have to know the angle that you're.
Yeah. Right. Yeah, there's things called Abney levels and clinometers that foresters use. There's other ways to kind of get this worked out, but you got to measure that vertical angle somehow, and the distance too. So why don't you find this one here? What's the elevation of B for that one? Now remember, you want this angle right here if we're going to use that formula. So the elevation of point B is the elevation of A plus the lowercase hi plus sine alpha times the slope distance minus the height of the rod. That's the formula.
Page?
Good point. Page is 356. 359. And remember, you're going to need to convert your angle into decimal too. I gave you that angle in DMS, so you'll need to use decimal for that. I want that angle in there. So I got my straight 90 minus that given angle to get that. I can't take 88.22 away from 90, so I turn 90 into 89 plus degrees plus 60 minutes. That way I can take away the 88.22 and get 138. But I want a decimal, so 1 plus 38 over 60 gets me 1.6. Carry at least 4 places past the decimal point there. You want as much accuracy out as you can get. It doesn't hurt to get a lot of accuracy out of that. That's what you want. Take sine of that times the slope distance, and I get 503. And then it's just a matter of following the formula from there. So the elevation of B is the starting elevation, 312.52. Add the little hi to get excuse me. That'll get you up to the telescope. You're going up 5.03 feet more. From there, that's the sine of the angle there times the slope distance. And then you're on the glass, then on the prism, and you're coming down 603 to get down to elevation of B. And that's 316.94. Okay. So that's the process there. Okay. So we doing all right with that? Any questions on that bit? Okay. Now this one here, what angle are you going to use there for right there when you do this one? Yeah, right. So the negative is important because you got to subtract that value this time. You don't add it, you subtract it. So it's going to be negative 432. And if you want to be real consistent mathematically there, what you're doing, you're taking 90 minus 94.32. You know? So that's the negative 432. And of course, you want to get that into decimal. You want to divide the 32 by 60 and all that. But watch your signs on this. If you're shooting downhill, your elevation will decrease. Okay. All right, so we got any questions on that? All right, so this Thursday, I think we'll do a little bit of a GPS lab here. We'll go out and just run around with the GPS equipment and do a little topo surveying out behind the activity center. Kind of where we did that grade stake little thing with the GPS. So that'll be Thursday. So next week is week 10. So that'll be our last week of class next week. We'll have finals the week after, same time as OSU. So Thursday's the 31st. Friday's the 1st. So Friday's the 8th. 6th. I think this is the 5th of June. So why don't we finish up this page here, and this page is 359, and then how about 1041, sketch up some contours for that grid there, and then that other stuff we were looking at where we kind of figured out what the range was on our map. So that's 1051 through 1053, I think, yeah. 1051 through 1053. Now the only thing you really need to turn in is 1053. That's your finished product. Okay. Doing okay with that? Okay. Good. So that stuff will be due Tuesday. So Thursday, we'll just run out. We'll just kind of hit a few points with the GPS stuff. Thursday. Okay.